So for the past few days, we have been using the percent proportion to find missing information, either the percent, the original, or the piece that we were using. And we use the formula percent over 100 equals is over of. Sometimes in a problem that sounded like part over whole or part over total. We're going to use a similar format and extend this a little bit. And now we're going to talk about percent change. So it's not just finding the information, but things have changed over time, and we want to find out by how much. So the problem is now going to become percent over 100 equals change over original, which kind of has that same idea of part over whole. We're changing a little bit of it, and then we want to know what the whole thing was, the original. All right, so this is called percent of change. If you need to look it up in your book, it will be chapter 2, lesson 5. There's two things that can happen. You can have a percent increase, which means it went up compared to the original, or you can have a percent decrease, which means it went down compared to the original. I usually remember D for down. If you're good with your prefixes, DE can actually mean from or down. It's a good way to remember it. All right, so let's look at our first problem here. Gas cost $1.30 probably per gallon in 1980. In 2010, it cost $2.95. What was the percent change? So I'm going to stick with my formula. You can set up that same line equals line, 100 on the bottom that we've used all along. I know because I'm looking for the percent, I can put my x over 100 right away. Now, I like to start with the original because I think it's obvious. Which of these two was the original? $1.30, because it was the one that happened first. Now we have to figure out how much it changed. So we're going to subtract. Some students like to do it off to the side. Some students like to do it within the problem. Whatever works best for you, do it. All right. So 295 minus 130, I get 165. Now it's going to feel weird that a lot of times these are going to be improper fractions, and that's okay. Remember, we're just setting up a relationship. All right. Now I've got a proportion. I can cross multiply. $1.65 times 100 and divide by $1.30. I get 126.923076. I don't need all of that. I'm just going to call it about 127%. Okay. What that means from this information, gas more than doubled over that time span, right? If we had 100 over 100, that means it was a 100% increase. It doubled. But we had more than 100%. It went up by a lot. 127% increase from 1980 to 2010. Okay, let's do another one. VR goggles normally cost $280. They are on sale for $220. What is the percent decrease in price? Stores love this. Saved by the Bell. You'll see flashy signs all over the place. A 25% discount. Save 30%. This is how they calculate it. All right, so we're going to set it up the same way. Line equals line, 100 on the bottom. I know I'm looking for my percent, so I'm going to put that X in there right away. The original, what's the original normal everyday price? In this case, 280. And here's where students tend to make mistakes. You cannot just pluck the information out of the problem. You have an extra step. You need to subtract and find out how much it changed. Now, something like this, I don't think I would bother writing it out. I know that 280 minus 220 is just plain 60. But you might want to get in the habit of writing this out just because then you will never forget to do this step. So our change is 60. The original is 280. I can cross multiply and then divide. And I get 21.42857143. I'm not writing all that. I think I'm going to call it 21.4 or maybe even just 21%. okay? If you use the squiggle equals and say approximately, you're fine. Now there's another way. If cross multiply divide isn't your favorite, because this is a fraction, you can simply divide these. And you get 60 divided by 280, 60 divided by 280. You're going to get that, but that's a decimal. We want it in a percent form. So then I simply scooch it twice, and I'm going to get that same 21.4%. All right, whatever works best for you. If you prefer to cross multiply, if you prefer to treat this as a fraction, either way is okay. Now, there's another wording that they might use, and it's called percent error. And basically, it's how accurate your guess is or how accurate your data is compared to what really happens. So if I was to take a survey of 7th graders at Glen Landing, maybe I missed a bunch. And that bunch that I missed would change my information. So I need to see how accurate or how inaccurate my information is compared to what really happens. All right, let's do this with food because everybody likes candy. In a jar, there are 400 jelly beans. I guess it was in a package or somebody counted, I don't know. Your friend guesses that there are 300. What is the percent error for this guess? How accurate or inaccurate was this guess? Well, we set it up the same way. Line equals line, 100 on the bottom, X for the percent. What's the original or the total or the true accurate number? 400. What's the difference or the amount this guess was wrong by? I know most of you would never ever write out 400 minus 300. It's okay. This guess was off by 100. Now, this is a case I would encourage you to not use the calculator. You know that 100 over 400 is 1/4, and I hope you know that 1/4 is 25%. If not, do the cross multiply divide thing. So this guess was off by 25%, which means it wasn't really all that close. If my percent error was maybe 7%, I'd say that was a pretty accurate guess. And if my percent error was like 52, yeah, that was a pure guess. That wasn't even close. All right, so let's talk about some steps. You're going to set up the frame like we've done the whole time, right? Percent over 100 equals change over original, line equals line, filling your 100. You're looking for the percent, so fill in your X. Figure out what was the original or the whole or the total or where you started with. The first one. That goes on the bottom. Then you have to do subtraction. This is perhaps the step that causes the most headaches because students forget. You have to figure out the change. Simple subtraction, no hidden steps here. And then that's going to go on the top. The answer from the subtraction, that difference, is going to go on the top. And then you cross multiply and divide, and you get your answer. All right? Very similar to what we've been doing, just adding in another thing that you can do with it.